The Webb is going to be able to look at planets that we've discovered around distant stars.
Betelgeuse has always been a captivating presence in our night sky, a red supergiant looming near the end of its life cycle, located about 642 light-years from Earth in the Orion constellation. Its slow pulsations, unpredictable dimming events, and spectacular scale, hundreds of times larger than our Sun, have made it a prime candidate for observation, speculation, and fascination among astronomers and enthusiasts alike. But the recent revelation shared by physicist Brian Cox has cast a fresh spotlight on this dying star. According to data obtained by the James Webb Space Telescope, Betelgeuse has suddenly surged in brightness by a staggering 250%. This sharp, unprecedented increase in luminosity has scientists captivated and, more importantly, challenged in their understanding of stellar evolution and the final throes of massive stars. Before we start, smash the like and subscribe buttons for more updates. The James Webb Space Telescope, with its extraordinary infrared sensitivity and resolution, was monitoring Betelgeuse as part of an ongoing effort to study its irregular behavior. Typically, Betelgeuse has cycles of brightness and dimming, often linked to convection cycles in its outer envelope. But this recent jump in brightness was neither gradual nor aligned with any known periodicity. Instead, it erupted as a sharp spike, a sudden blaze of light from a star already among the brightest in the sky. Unlike its previous dimming in 2019-2020, which was attributed to a partial ejection of surface material and subsequent dust formation, this new event appears to be intrinsic. It isn't merely a surface phenomenon masking the light, this is Betelgeuse genuinely becoming more luminous. Such a dramatic change is rare, not just for Betelgeuse, but for any known red supergiant. These stars are typically in their twilight years, burning through the last of their fuel in massive, chaotic nuclear reactions, often resulting in unstable outbursts. A 250% increase in brightness suggests an event of tremendous energy, far beyond standard convective turbulence. While astronomers hesitate to jump to conclusions, this level of brightening might point to processes happening in Betelgeuse's core, potentially signaling the early stages of collapse or a severe instability that precedes a supernova. Even without the definitive conclusion of imminent explosion, the physics behind such a burst remains a compelling puzzle. James Webb's readings reveal more than just visible light intensity. Its ability to peer into the near and mid-infrared spectrum gives it unparalleled insight into the thermal structure of Betelgeuse's extended atmosphere. Observations from the telescope indicate increased infrared emission from the outer layers, suggesting they have heated considerably. This isn't just a matter of the star getting brighter in the optical bands, it's a total energetic ramp-up across the spectrum. The implications are profound. Betelgeuse may be undergoing one of the final stages of stellar evolution known as carbon or neon burning, where elements fuse in ultra-hot conditions inside the star's core. These are the last brief, violent chapters before the star can no longer hold itself together. What makes this event especially riveting is its suddenness. Red supergiants evolve over thousands to millions of years, and their fluctuations, though dramatic to us, are typically part of long-term cycles. A 250% brightness increase in such a short time frame is an anomaly, a spike that defies the expected rhythm. This challenges current astrophysical models and forces theorists to reconsider how late-stage stellar dynamics truly function. Perhaps the models we use to simulate the life cycle of massive stars are incomplete, lacking the nuance to explain such rapid and energetic episodes. For astronomers, this brightening is a golden opportunity. Every telescope pointed at Betelgeuse now acts as a witness to a real-time stellar drama, offering clues to processes that previously existed only in simulations and fragmented observations. Ground-based observatories, space telescopes, radio arrays, and even amateur astronomers are scrambling to collect data. The synergy between observatories on Earth and the James Webb Telescope's vantage point in space allows for a multi-layered perspective. Webb sees the deeper, cooler layers, while others track the surface activity and spectral shifts. Together, they're weaving a comprehensive, evolving portrait of a star in flux. The idea that Betelgeuse could be nearing a supernova has long danced at the edge of public imagination. It's one of the very few stars close enough and large enough for its death throes to be visible from Earth, even during daytime. A supernova in Betelgeuse's position wouldn't threaten life on Earth due to its distance, but it would be one of the most visually spectacular events humanity has ever witnessed. However, this 250% increase in brightness, while dramatic, does not necessarily mean a supernova is imminent. Stars can experience several violent outbursts before finally collapsing, and this might be one of many unpredictable flares to come. Still, each one of these flares becomes an essential chapter in the biography of Betelgeuse, revealing layers of complexity in how massive stars live and die. The energy involved in such an increase is staggering. Betelgeuse, even in its normal state, emits tens of thousands of times more energy than the Sun. A 250% increase implies a temporary output exceeding even that, perhaps hundreds of thousands of solar luminosities. Such energy cannot come from surface changes alone. It likely originates from deeper convective zones, or even from shifts in the fusion rate at the core. If the latter, it's possible that Betelgeuse has transitioned into a new phase of nuclear burning, one that could be inherently unstable and subject to sudden spikes in output. Alternatively, massive convection cells, so large they could span a third of the star's diameter, might have dredged up superheated material from inside the star and released it at the surface in an explosive burst. This event also invites comparisons to other red supergiants and how rare such phenomena might be. Perhaps Betelgeuse is simply an outlier, a highly unstable stellar elder reacting erratically in its final moments. Or maybe it's part of a broader pattern, a sign that red supergiants are more dynamic and unpredictable than previously believed. If other stars in this category exhibit similar behavior, it could point to a phase of stellar life that is underrepresented in models. A high-precision survey of similar stars using James Webb and other space-based instruments might reveal that we've only scratched the surface of how these colossal entities behave near the end. The implications ripple beyond just Betelgeuse. If sudden surges in luminosity are more common than thought, it raises questions about the pre-supernova warning systems that astronomers hope to build. Right now, the best models suggest neutrino bursts or gravitational waves might be our first clues that a star is about to go supernova. But if brightening events like this occur months or even years before the end, they might provide an earlier signal, one that can be detected across great distances and interpreted in advance. That would revolutionize our ability to observe the birth of supernovae in real time, with precision instruments already trained and ready for the light show. This also intersects with another area of astrophysics, the chemistry of galaxies. Massive stars like Betelgeuse play a vital role in seeding the cosmos with heavy elements. When they explode, they scatter the building blocks of planets, life, and new stars into space. Understanding how and when these explosions occur is critical to modeling the evolution of galaxies, including our own. If stars have unpredictable surges of energy before death, it might change the timing and dynamics of this cosmic recycling process. Perhaps these energy bursts precondition the surrounding interstellar medium, shaping it even before the final supernova clears the stage. The role of the James Webb Space Telescope in all this cannot be overstated. Its infrared eyes can pierce through the dusty shrouds that often surround aging stars, revealing details invisible to optical telescopes. Its data on Betelgeuse's recent outburst is not just a record of a dramatic event, it's a treasure trove of information on stellar physics, convection mechanics, radiation transport, and possibly even magnetic activity on a scale never before observed. For the first time, astronomers can observe a red supergiant not just as a flickering light in the sky, but as a living, evolving system with depth, structure, and unpredictability. And it's not just the raw data that's useful. Webb's capacity to track changes over time, to conduct detailed, time-resolved spectroscopy, and monitor subtle shifts in temperature and composition gives researchers an evolving view of Betelgeuse's atmospheric dynamics. That means that the next few months could reveal whether this brightness surge is an isolated event, the start of a pattern, or the herald of something much greater. Already, early spectroscopy has shown that Betelgeuse's outer envelope is expanding, possibly in response to internal pressure waves. This inflation, if sustained, might point to deeper structural instabilities. The astrophysics community is energized by this development. Observatories across the globe have triggered what are known as target of opportunity protocols, dropping scheduled observations to prioritize Betelgeuse. These moments are rare in science, when a single celestial object becomes the focal point of nearly every major instrument in the world. From Hawaii to Chile, from space telescopes to Antarctic detectors, the eyes of modern astronomy have turned toward Orion, watching and waiting. There's also a sense of urgency that comes with studying Betelgeuse right now. If it is on the path toward a supernova, we may be experiencing some of the final observable moments of a star that has fascinated humans for millennia. Even if the end doesn't come for decades or centuries, each flare-up like this becomes a key piece of the timeline. It's a reminder that the cosmos is not a static tableau, but a theater of continuous transformation. Betelgeuse is a titan on the edge of an unknown destiny, and we are its closest witnesses. As the weeks progress, the astronomy community hopes for more clarity. Will the brightness recede as suddenly as it rose? Will it plateau, suggesting a new phase of activity? Or could we see further increases, a cascade of energetic events signaling deeper collapse? No one can say for sure. What is certain is that Betelgeuse, once again, has captured our imagination and our curiosity. It has drawn back the curtain on a moment of cosmic drama, reminding us that even the most ancient stars can still surprise us. This 250% surge in brightness, brought to light by the unparalleled capabilities of the James Webb Space Telescope and the sharp attention of scientists like Brian Cox, is more than just a spike in luminescence. It's a call to attention. It urges humanity to look up, to study more deeply, and to marvel at the forces that govern the birth and death of stars. For those watching the skies, this is not just a blip or an anomaly, it's a revelation. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on Betelgeuse's 250% brightness spike, supernova soon or not? We want to hear from you. Thank you for watching and see you next time.